Welcome to Lecture 3 on Politics and Governance of Sensing. This is part of the Sensing Revolution topic, which is a topic covered in the subject Agricultural Technologies, ALM207. This subject is offered in the agricultural degree at the institution of NMIT. My name is Dr. Nikki Cooley. The purpose of this lecture is to give a snapshot on some of the issues of politics and governance in sensing. Please note that any commercial sensors described in these lectures are not a recommendation or an endorsement, but simply an example of the technology. There are often many excellent examples of commercial sensors, and if they are not covered in this topic, it is not a reflection of their functionality, reputation, or performance. In this lecture today, we will cover the role of governance in sensing. We will look at risk management and safety of sensing. We will also touch on the role of politics in sensing. GRC is used as an abbreviation for governance, risk management and compliance. GRC in sensing is the integration of governance, risk management and compliance in this industry. These policies are influenced and informed by education, research, applications and operations, as well as development initiatives, and are often connected to policies and governance. The area of GRC in sensing is very large, and it tends to depend on specific characteristics or criteria of the sensing technology itself. Therefore, in order to describe the concepts of this topic, I am going to use the geospatial industry as an example. The geospatial GRC is applicable to surveyors, engineers, photogrammatists, GIS professionals and other professional bodies that all have policies and procedures which enable them to operate and maintain responsibilities among their membership. It is often worth noting that businesses often refer to policy as research and development, and we have all known cases where policy has changed, often dependent upon new leadership or organisational direction. But policy change may also be due to new information and awareness. It is on this point where governance begins. So using geospatial governance as an example, we are going to talk about and examine the issues in this industry. Governance is more about expectations and acquiring information and data pertaining to those expectations. For example, clean water, less noise, low crime and safety, and security are all expectations that each of us have. Geospatial technologies and applications provide the tools and knowledge for gathering information about these factors. Can you see radiation? Can you tell when a school is needed in a neighbourhood? Do you know when it will flood or rain? Which fields are the best for wheat, oats or barley? Do you know where the pipes are in the ground? Can you calculate the level of production across Europe in your head? Geotechnologies enable us to locate, measure, monitor and model all of these factors. They support governance. They provide many of the primary sources of information we need to govern the way we live. GPS can be used to locate events and processes, GIS to map and analyse them, surveying equipment to measure them and remotely sensor or monitor them. Collectively, they can all be managed together. This conversion or fusion of information and knowledge then shifts from simple data to information and later becomes knowledge upon which decision making is based. Clearly, a process is involved. Consequently, we can see governance as being closely related to processing. Let us look at legislation. Legislation is policy set in the case of health environmental fields. Laws and policies have resulted that include monitoring, implementation and results. For example, the Common Agricultural Policy, or CAP for short, in Europe is an example of this, where producers are paid depend upon production. Satellite imagery analysis of land base is used to determine which areas are being monitored and used to calculate payments. On the other hand, geospatial technology can also be used to develop and set policy. An example of this would be setting of insurance rates. depending upon flood potential. In this case, digital elevation models can be used to develop flood risk maps. Standards adoption and innovation. In the US, the federal government assists much influence in the promotion and adoption of industry standards and practices. This investments of larger government agencies serve to provide a catalyst for change and to spur widespread adoption of standards and technologies. The approach of the National Geospatial Intelligence Agency, or NGA for short, has been a great influence of geospatial standards adoption, particularly in the last 7 years. NGA has exerted strong influence through its support of the Open Geospatial Consortium and its establishment of the National Centre for Geospatial Intelligence Standards. Australia has its own Defence Imagery and Geospatial Organisation. The link for the website is on the screen. Much of the standards from the US have been adopted, but Australia has also adopted specific legislation for Australia and its surrounding issues. The Office of Spatial Policy, or OSP, is a central policy unit in Australia responsible for facilitating and coordinating spatial data management across Australian government organisations. The HTTP link on the screen is given for your information. Another important component of governance is the Sensing, Communications and Governance, or ACMA for short. This is applicable to the food industry. Widely adopting sensing and monitoring technologies in the food industry's production, processing, distribution and sales process. In this, sensor networks are described. They play an important role in minimising the risk of hazards to poor quality food products being sold for human consumption. Sensors can be used to track, trace and monitor products by employing transducers that measure immediate environmental aspects such as light, heat, moisture, location and time that are important to the quality management of perishable products. Some examples listed by the ACMA include the Australian viticulture is using sensing and monitoring in the growth of grapes to measure wind speed, temperature, light, humidity and soil moisture in order to conduct analysis that helps optimise plant growth and prevent crop loss through climate factors such as excessive heat, light or frost. Live produce may also be monitored from the primary producer to the dinner table. Australia uses the National Livestock Identification System, or NLIS, to identify and trace livestock such as cattle, sheep and goats. NLIS allows individual animals to be identified and tracked from the property of birth to slaughter for biosecurity, meat safety and market access. Livestock traceability improves overall product integrity by assisting in disease management and continuous animal monitoring through feed and weight sensing. The system relies on radio frequency identification (RFID) tags that are attracted to the animal's ears or inserted under the skin. Sensors are used to identify livestock when moved from location to location, to update information about individual animals or a centralized NLIS database. Applying sensor network technology to manage and monitor the movement of perishable products from the producer to the reseller is significant in minimizing loss, maximizing quality, and complying with certain legal obligations. On the slide, a visual representation of NLIS wireless sensor network application is shown. It just shows the tag manufacturer, the producer, the sale yard, the feedlot and processor, and where the NLIS database coordinates all this information. The following case study is on smart trace systems as described in the ACMA. Please stop the presentation here and read through this documentation. You will be able to download this documentation from Moodle if you are unable to read the attached slide. Once you have read the article from the ACMA on sensing and monitoring the smart trace system, please answer the following questions. Recently, the ACMA has done a review of technologies in Australia. From this review, recommended regulatory implications have been suggested. The ACMA is interested in the ways emerging start technologies affect service delivery to consumers. The ACMA views sensing and monitoring technologies as smart technologies that will have a potentially significant impact on how information-based services are developed for use by consumers. The recent review in Sensing and Monitoring Recent Developments, conducted by the ACMA, concluded that device numbers had significant implications onto policy and governance. They stated the advent of the Internet of Things introduced a raft of regulatory implications in what is already a challenging technological and operational environment for industry and consumers. The sheer number of devices will require new processes of connection and management. In the future, the majority of communication devices will be associated with a function and a service that does not involve a person. Devices will need to be interlapable with a variety of networks and be able to autonomously join and leave networks as required. Trusted relationships between consumers and industry will need to be extended to devices. Addressing a predicted population of devices in the order of tens of billions will require new technology to deliver reliable, scalable and accessible services. The IPv4 addressing scheme has only 2 to the 32 or 4.3 billion addresses and is nearly exhausted. These are an example of some of the issues that are faced with policies. Another such issue is the issue of security, and certainly one that faces challenges for the agricultural industries. The Internet Protocol Security, or IPsec, is integrated in the design of the IPv6 architecture and is mandated as a fundamental interpreteratory requirement. IPv6 also has an inherent network security capacity, and this is important. It provides for standardized end-to-end encryption and/or authentication at the network layer and may be deployed to protect any upper layer application. These are examples of some of the policy and governance. Wireless and cloud environments present some issues too. Embedded mobile sensors and their associated services depend on wireless networks to offload their data to back-end services in the cloud. The cloud provides unprecedented scalability and resources for the collection and analysis of large-scale sensor data. This too could be exceptionally useful to the agricultural industry. Utility companies and others that provide critical services need to also consider their reliability of their services. While some services such as email, telephones, data and consumer support are now being provided by cloud environments, sensor monitoring for health and critical infrastructure will require robust operational and redundancy capabilities to avoid life-endangering outages. Identity management is another possible issue of the future. Identification of and responsibility for such devices as an area of interest for the ACMA, which aims to ensure the community continues to benefit from spectrum aspects and is protected from unsolicited communications. This prevents an environment which is increased cybersecurity risks to sensitive information and infrastructure assets. For example, the Stuxnet worm is malicious software that targets industry software to subvert programmable logical controllers, or PLCs, that interface with sensors and actuators. This is an example how this kind of security can be a big risk to agricultural users in the future. Certainty in data ownership, security and rights of use are important foundations for functionality digital economy. Data can be collected from many sources such as private sensor networks, crowd sensing, from smartphones, traffic matrices, from network operators and services, and application usage by users. Ownership of data, data privacy and choice are relevant consumer issues. Consumer also being increasingly aware of invasions of privacy through direct harvesting of information by application and service providers. Some of the ACMA findings of solutions are highlighted below. Electricity smart meters, electronic smart card ticketing and tool tags are examples of sensoring and monitoring applications that have met consumer resistance. Liability for actions of autonomous systems is also a concern when multiple entities are involved in the provision of services to consumer. It should also be noted that a law is only as good as it can be policed. Significant challenges for this technology are in the future. That brings us to the end of Lecture 3 on Sensing, Politics and Governance. I hope from this that you have begun to have a bit of an understanding of government's risk management and compliance in sensing, the role of policy and some of the complicated issues surrounding this topic. ACMA concerns, issues and possible solutions with sensing governance have been discussed, as well as a smart trace system case study presented.